What's poppin', dogs? Mr. Allen here with some solving of systems of equations, but we're not dealing with the old, two linear equations. We've got quadratics in this bad boy. So let's start with this one here. One linear, one quadratic. How are we going to solve this? Well, rather than doing something like elimination method like you may be accustomed to, we're actually going to use substitution. And generally speaking, we're going to have these two both equal to y if they're nice about it. So if they both equal y, I can just set them equal to each other. I'm going to put this guy over on the left, and this guy on the right to start this thing out. And the reason I'm doing that is because I see that I'm going to have myself a quadratic equation that I need to solve. And the way I'm going to solve a quadratic equation is by setting it equal to 0, and then hopefully being able to factor it, my favorite F word, and then solving from there, okay? So x squared plus 6x minus 20 equals 2x plus 1. Let's subtract the 2x and subtract the 1. And, I kind of just jumped into this thing here, getting all excited to start solving for x. What's our solution going to look like? Any thoughts on that? Well, a solution to a system of equations is where the two lines intersected, right? We were just dealing with straight lines. So now I have a positive quadratic, and I have a line that's sloped. There's the potential for actually two solutions here. And my solutions should be ordered pairs. Let's keep that in mind as we finish solving this thing, okay? So over here, I got to set this equal to 0. I'm going to factor if possible. Does anything multiply to negative 21 and add to 4? Yes, it does. So I have x plus 7 and x minus 3 equals 0. So I'll get x plus 7 equals 0. So x equals negative 7. And x minus 3 equals 0. So we get x equals positive 3. I like to write those out, okay? I know it might seem like a lot to just write it out equal to 0, then solve it. Can I just do the opposite? Yeah, you can until you screw it up later on because you start doing opposite. I did too many opposites. You undid the opposite, and now you got the wrong side. Okay, we don't want the wrong side. We want the right side. We want to do these problems right. Get hunas, okay? That was 100%, okay? Anywho, are we done? No, because we just said my solutions are points. They're ordered pairs. So I'm almost done. My final answer will be negative 7 comma something and 3 comma something. But I got to figure out that something, okay? And the way to do that is let's plug it back in. Easiest one to work with is this bad boy right here. It's linear. I don't have to square anything. But you could use either one if you want. All right, so I'm going to substitute back in. I'll do that in a different color here. We have y equals 2 times negative 7 plus 1, so that's negative 14 plus 1, which is negative 13. So this one is negative 7, negative 13 for an answer. And then for 3, I've got y equals 2 times 3 plus 1. So that's 6 plus 1, which is 7. Boom. These are my two solutions. Cool? Ordered pairs. Got to be ordered pairs. What I would suggest doing on my test, if I were giving a test in Algebra 2 Honors this week in 2 days, when I'm making this video right now, in future years, it will not be. It'll be a year and 2 days or something. Anyway, I would write this part down in green, and in green on my answer line, right? Or even just two ordered pairs. I know there's probably going to be two solutions. There could just be one. There could be none. But let's write down some ordered pairs, figure out what those answers are. That way you don't just put these two there and only get 2 out of the 4 points that this particular problem happens to be worth on your test. Anyways, I'm going to move on. I was getting a little hot there. All right, this one. I have two quadratics, one positive, one negative. So it could probably look something like that, right? Still, dos solutions possible. Or no solutions, or one solution. But I have a feeling it's 2 because I wrote the problem. Anyways, if they just like touch and like they bounce off each other, that'd be a one solution situation. Or if this dude was just, running tangent to the quadratic, the parabola there, if it was running tangent to it, one solution. Tangent means it just touches at one spot. All right, let's set these things equal, shall we? I'm going to put the big dog with the 4 on the left, the other one on the right, okay? This is going to be a long thing. It's going to probably go across my face right here. So hopefully it's okay. Let's see here. 4x squared plus 28x plus 17 equals negative x squared minus 2x minus 8. All right, and now we got to solve this thing. So we're going to set it equal to 0, right? So we would have, let's see here, we're going to add x squared. So we've got, actually I'm going to write it, yeah, we'll do, I'm going to bring it back over here. 5x squared. And then I got to add 2x, so I'm going to get 30x, so plus 30x. Then I'm going to add 8, so I get 25 equals 0. Okay, sorry for the moving of the equals. It just works better on the board. All right. Interesting. 5, 30, and 25. Aren't those all divisible by 5 or 5? You can do this, guys. This is totally legal. I can divide everything by 5. You're like, well, what about 0 divided by 5? That's just 0. Bet you were thinking that. You were just thinking that in your head. You're like, how do you know that? All right. X squared plus 30 divided by 5 is 6x. 25 divided by 5 is plus 5. And now, can we factor this? Yes, we can. And it's a lead coefficient of 1, which is so much better than a lead coefficient of 5. I've got x plus 5, x plus 1. It's got to multiply to 5, add to 6. People always screw this one up, and they do 2 and 3 instead. They accidentally multiply to 6, add to 5. They flip it around by accident. It's always multiply to the constant, add to the coefficient of the linear term. So now I have x plus 5 equals 0, and x plus 1 equals 0. So x equals negative 5, x equals a negative 1. But are we done? No, we are not done. But I am going to write my ordered pair. So I've got negative 1 comma something, and I have negative 5 comma something. And hopefully we can still see those. Hopefully they're on the board. I don't know if my watch will update. It doesn't always update. Okay, well, hopefully it is. Anywho, let's do this in a different color. We're going to substitute these back in. I think I will go with this one here, because even though it's a negative lead coefficient, they're smaller numbers. It is kind of on this one. So I have y equals negative 5 squared minus 2 times negative 5 minus 8. This is negative 5 squared, which is 25, but it's still negative. So negative 25. Don't do negative times negative is positive. That's not correct. Okay, that is not correct. This one here is negative 2 times negative 5, which is positive 10. And then minus 8. So this right here is what? Negative 15 minus 8 is negative 23. I really hope that's right. It'd be embarrassing if it's not. But hey, man, it happens. You can even do it another way. Negative 25, negative 20, or negative 8, negative 33, plus 10, negative 23. Yay! Checks out. All right, next one here. We'll put negative 1 in. So y equals negative 1 squared minus 2 times negative 1 minus 8. Man, we're running out of room here. That's an 8, kids. That's an 8. So I've got negative 1 squared is 1, but it's negative on the outside as well. So negative 1 plus 2 minus 8. That is negative 9 plus 2 is negative 7. We can think of negative 1 plus 2 is 1 minus 8, negative 7. Either way you slice it and dice it. We got our 2 ordered pairs here for these 2 quadratic systems. Whew. That's a lot of math, man, but it's beautiful. It's beautiful. Mathematical poetry. Thanks for watching, you guys, and you have a fantastic day. Good luck on your test if you got that coming up. If you're studying that last-minute grind right there, crush it or be crushed. I'm going to say the former, not the latter. Crush it.